This is another brick in the firewall, how to secure your Azure Data Platform. Before we go into the technical, just to introduce myself a little bit. So my name is Grace O'Halloran. I'm a principal data engineering consultant at Advancing Analytics, but I've been working with Azure Data Platforms for almost 8 years now. I'm recently awarded Microsoft Data Platform MVP, and I'm also a Microsoft certified Azure developer and administrator. All of my socials and stuff are on the bottom, so if you want to connect with me on LinkedIn, please feel free to do so. I also have my blog on there, which is Thinking a Cloud. I post lots of stuff on there around data platforms and networking and infrastructure. And then I also have my community content GitHub at the bottom there. So these slides, along with all the other slides for all the other sessions that I do, will always be on there. So if you want to find them afterwards, I can always share them with Mikey as well to send out via the user group, but you can also find everything on my GitHub. So this is what we want to talk about today. And this talk essentially was born from the conversations that I have with my clients in capacity of a consultant. So my area of specialism focuses around network security of data platforms and infrastructure as code and DevOps and kind of that side of platform engineering, I guess, as well as the data engineering stuff. And a lot of my clients, especially these days, and you guys might have similar experiences, all of them really want privately networked data platforms now. Everything should be privately networked and locked down. And that seems to be the norm. And I think, especially in the cloud, and especially as data people, we don't necessarily realize the implications that decision has. And so each of these sections on the agenda here are essentially all the different things that I would then talk a client through when they've made the decision that they want to deploy their platform into a privately networked environment. So as you can see, there's quite a lot of stuff that you need to consider. So I do data. Why is this relevant to me? Is what often people say to me. And I think there's a couple of different answers to that question, right? But I think, as I mentioned, especially working in the cloud these days, data engineers, platform engineers, and other such roles, I think, have been given a lot more autonomy to just create stuff that we didn't have before in an on-prem environment, right? And so sometimes with, that responsibility or with that power, you also then have responsibility. And sometimes we don't always know enough to make sure that we're being responsible with what we're creating. Another reason why I think this is important is I don't know what your guys' experience are, but often we might not be the ones that are responsible for building the network components, but we need to integrate with them. We need to make sure our solution works with the wider Azure estate and that it's all connected up. So knowing enough about the basics to go to a central networking or infrastructure team to ask them sort of more specific things tends to make things go a lot quicker and tends to remove blockers quicker, right? Instead of going to someone and saying, this doesn't work or this can't talk to this, you can go with more targeted questions, and they usually appreciate that as well. So the theme of this talk is not necessarily me telling you all these things because you need to know how to do them and how to configure them and how to deploy them. It's more you need to be aware that if you decide to deploy stuff in a privately networked environment, all this other stuff has to now be done. And you need to communicate with the relevant people in your organization to get these things configured. So a little bit of history here. So people may have heard of this before. It's a cybersecurity approach or framework called Defense in Depth. And essentially it recognizes that each layer within this approach adds a barrier, right? And it recognizes that no one layer is enough to protect your data and your applications. And so we're not necessarily responsible for all of these layers. For example, physical security. Microsoft are responsible for, ensuring the physical security of their data centers, for example. And then as data people, some of these other ones come a bit more naturally to us, like maybe data, like encrypting data or identity and access, using Entra and RBAC roles and things like this. But for me, networking is the one that it kind of lies in the middle where we have some responsibility and oversight of it, But as data people, it tends to be the area that we have the least amount of exposure to or least amount of experience with, in my experience anyway. So this is the area where I think there's an opportunity for upskilling in the data world. And ultimately, it saves everybody a lot of headaches if we understand it a little bit better. So that's kind of why I think it's important, even as a data person, to understand a little bit of network security when it comes to your data platforms. Okay, so I'm going to take you through a journey now. Imagine that we're deploying a new data platform in the cloud, and we've decided that we want to do it within a privately networked environment. Okay, so what's the first thing that we need to do? Well, we need a network, right? So I want to first talk about hub and spoke topology. You may have heard of this before. A hub and spoke topology is essentially a network architecture that has a hub network in the middle that acts as kind of like a central gateway. And then there's a bunch of spoke networks that are connected via VNet peerings all around the outside. Okay. So you'd have your hub network with some centralized shared infrastructure in there. We'll talk a little bit later about specific things that you might expect to find in a hub. You would expect to have this as your central gateway for all things coming in. So for example, you might have an express route in there that connects to your on-prem corporate network. And then you'd have multiple VNet peerings coming off that for all your spoke networks around the side. Now, what constitutes a spoke? Now, that can differ from company to company, from organization to organization. Some companies I've seen, they just have one big dev spoke, so one big dev VNet, one big test VNet, one big prod VNet. Others I've seen it much more granular, where you would have a VNet, a spoke VNet per application, per environment. So in our instance, deploying a data platform, we might have a dev data platform spoke, and then there might be like a dev AI platform spoke or something like that, or a dev web app spoke or something, for different solutions and different platforms. So the first thing you need to understand is, how does your solution fit into this hub and spoke topology? Most people tend to use hub and spoke topologies these days. It's kind of recommended best practice by Microsoft. So we need to understand how we fit into this. Do I need a new spoke? Is there a bigger spoke that I can slot myself into? That's kind of the first thing that we need to understand. We need to get a lay of the land and figure out where we fit into it. Once we've figured that out, the next thing is, okay, how much space do we need, right? So that's actually quite a tricky question to answer. But it's really important to think about before you start building stuff, because you don't want to be in a position where you end up running out of address space. So if you need a new VNet, how big do you want that VNet to be? If you're slotting into an existing VNet, how big do you need the space within that VNet for your additional subnets? Now, subnets are just a logical way of splitting up a virtual network. They're literally sub networks. They're mini networks within a network. Think of them like folders for your files. So if you're slotting into an existing VNet, how many new subnets do you need, and how big do you need them to be? So a couple of things to think about, because although you're not necessarily going to be the one provisioning the VNet, you're going to be the one asking for a VNet. And the first question you're going to get back is, well, how big do you need it, right? So one thing to consider as well is you need to be aware of avoiding conflicts. So with a hub and spoke architecture, every spoke within that architecture is peered to the hub. And so what you essentially end up with is one big network. So you can't have any overlapping address space within the entire network. So if you just create your own VNet and you've not thought about the IP address space, and then you peer it into the rest of the architecture, you could end up with overlapping IP address space between your network and one of the other networks in the overall architecture, which can cause all sorts of issues. So important to not just start throwing around address space willy-nilly. Something you can do to combat that is by just using and respecting IPAM processes. So IPAM is IP address management. Usually you would expect your central networking or infrastructure teams to have some kind of IPAM system, which could literally just be a spreadsheet, right, of all the different networks and what all the different IP addresses are. And they should be able to look at that and tell you what address space is unused, and give you some address space that you can then use for your network. Next thing is size requirements, as we discussed. How big do we need this network to be? Again, really tricky. Anything that has an endpoint needs an IP address, and any kind of compute needs IP addresses. And compute is the one where you can really rack up size very quickly. Think about Databricks clusters, for example. Each node within a cluster is its own computer, so it has its own IP address, right? So if you have a very, very large cluster, you could quickly be using tens or even hundreds of IP addresses. So thinking about your compute requirements means you also have to think about your data processing requirements, right? How quickly do you have to process it? How much data do you have to process? All of that helps you answer how much compute do I need, and all of that helps you to answer how big does my network need to be. So you see, all of a sudden you have to start thinking about a lot of things up front and way earlier than you potentially considered previously in a non-networked environment. And a tip with that, I would always allow for growth, whether that's scaling up or scaling out. Add a little bit of extra space in your subnets if you need to scale things up, but also add a few spare subnets if you want to add things into your architecture, right? You might have a whole new service that you want to add later down the line. If you've not got the address space for it, that's going to be very, very difficult. So always allow for growth and plan for scaling. Okay. So we've thought about the network, we understand where our network's going to sit within the rest of the architecture, and we understand what address space we should use and how big it will be. Now we need to think about how do things come in and how do things go out, right? So that's where ingress and egress come in. And ingress and egress are just fancy words for inbound and outbound, okay? And that's a quote from me now. And obviously it's a little bit more complicated than that, but essentially ingress and egress are from non-trusted to trusted source and vice versa. But you can think of it as inbound and outbound, right? Your internal environment being trusted and the external environment being non-trusted. So some things that we need to think about. In a hub and spoke topology, all ingress and egress goes through the hub, as I kind of mentioned previously, right? And this provides a level of separation between the spokes and the outside world, essentially, right? And it minimizes the number of entry and exit points in your network. I like to think of this like a bank, if we still have physical bank these days. I know they're few and far between, but imagine you have a big bank that has loads of vaults in it, right? Loads of secure vaults. If you wanted to get to a certain vault and you had authorization to get to a certain vault, you'd go through a big gate, presumably through a big front door. You'd go to a central desk. There'd probably be a security guard. They would check your credentials. They'd sign you in. They'd track the fact that you're there. And then they'd probably direct you to your specific vault to make sure that you're not wandering around the building, right? What you wouldn't want is for every individual vault to have its own door straight to the outside street, right? You wouldn't want people just walking up from all around the building and coming in and out of all the different vaults. That's so much harder to track who's come in, who's come out, whether they should be coming in and should be coming out. And it's more expensive to employ multiple security guards across all of those different doors, right? It's the same concept with your hub and spoke. You have one central place where people can come in and out, and then you manage where they can go from there to your individual spokes. And the position of the security guard in this instance is essentially filled by a firewall, right? It's best practice to have a firewall in your hub so you can monitor what traffic is coming in and what traffic is going out, and you can block and restrict certain things as well. So I've got an example of a VNet here. This is my hub, and I've got a firewall in there which has an IP address associated to its front end endpoint, right? And I've got a spoke, let's say, and I've got a VNet peering that spoke to my hub. And anything that's coming in or out, whether that be from a trusted source, like maybe our corporate network over an express route, or from an untrusted source, maybe from the internet, that should all be going in direct via the hub and should be routed directly to the firewall, right? Why am I telling you this? Because it's important to know if there are firewalls, right? If you're trying to get from on-prem to your spoke, you're trying to log into something, or you want things in your spoke to talk to things outside in the internet, if things need to go via the firewall, it's important for you to know that has to happen, right? It's important that to know that you may need to request firewall rules to be added to the firewall, right? If everything is locked down by default and you try and connect to stuff and it's not working, it might be because you've not got a firewall rule and you have to actually request that firewall rule to be added. So it's important to understand what firewalls you have in your architecture to know what you need to integrate with. Another thing that's important to note as well is whether you have a requirement to send all spoke-to-spoke traffic via a firewall. So going back to the bank example, if you've been directed to a particular vault A, but let's say you also have access to go to vault B, they probably wouldn't want you just wandering from vault A to vault B. They'd probably want you to go back to security first, say that you finished in vault A, and then they will take you to vault B, right? That's the same concept. A lot of companies do that, where even though you're already in the network and you're in a spoke, they still want you to go back to the firewall before you go to another spoke. And this is achieved through things called UDRs, or user-defined routes. And I've got a picture of one here. It's just a route that's added to a route table, and a route table is attached to a particular subnet. And it says anything that, any traffic that tries to leave this subnet, first go to the firewall, and then it'll continue on from there. Again, important to know that if this is a policy that's required from you, is all spoke-to-spoke traffic required to go via a firewall? In which case, you need to make sure either you're adding these route tables to your subnets or you're asking someone to add these route tables to your subnets. Another icon you may have noticed on that diagram was a network security group, or an NSG. So what is an NSG? Well, they are essentially mini firewalls for your subnets. They're not as big or as complex as like an Azure firewall that you would have in the hub, but it gives you a little bit of control over your own spoke. If you remember, I said subnets are just mini networks within your network. You can think of them like folders. It gives you a way to wrap a firewall around each one of those areas to provide further segregation within your solution. It's simply a list of rules, right? Of inbound and outbound rules, allow or deny, and you can restrict it based on IP addresses, Microsoft services, and ports and protocols. So an example where you might want to use this, I've got a hub and spoke architecture here. This time I've made the hub kind of smaller, and we've got our spoke here. This is a very simple kind of platform example. I've got a SQL database and I've got a VM, right? And in this example, let's say I only want users to be able to see the SQL data through the VM, because maybe I'm implementing something on the VM that implements row-level security or something like that. And I don't want them to be able to access the SQL database directly. So what I can do is I can put the front end and the back end of my platform into two different subnets and put network security groups on these subnets that have different sets of rules. So if this user tries to go to the VM, I can have a network security group rule that says, yes, anyone that's coming from on-prem via the express route, via the hub, via the firewall is allowed to come into this VM. Okay. If they tried to go log into the SQL database, however, I would have a rule on this NSG that says deny anyone coming from on-prem, right? Or specific subset of users. So you can see how this provides more granular control over who can get in to different parts of your platform. So this is definitely something that you would be responsible for if you're sort of deploying your platform. This is very isolated to your spoke. It doesn't really impact what anyone else is doing. And so you're more likely to have control over NSGs. Okay. Secure development access. Now, this is a big one, and it's one that people often forget about. And it's happened to me in the past where we've focused so much energy on securing a data platform that we've deployed it and then realized that we can't get in ourselves, and we need to get in to develop and do stuff, right, and build things. Now, if you don't plan for this, what happens is you end up with people just poking holes in the network, adding your IP address to the SQL Server firewall or anything like that, which I've definitely done in the past. But we don't want to be doing that, because that's essentially going up to the bank and kicking a hole in the outside wall and just walking straight into the vault, right? It's bypassing all of our security measures that we've worked so hard to set up. So it's really important to consider secure development access up front. Now, I'm not going to spend too much time on this because I think most people will be familiar, but there's so many different tools you can use. You can use a virtualization tool. Azure Virtual Desktop, Windows Cloud PC is a really popular one that I use a lot at the moment. Or you've got your more classic tools like Citrix and VMware. You've also got Microsoft DevBox now, which is kind of like a virtualization. It does require pre-configured workstations. But I've used that too, and that works really well from an end user perspective. You've also got Azure Bastion. It's very expensive, and to be honest, these days I don't see many people using it anymore. Bastion essentially provides a secure host, kind of like a DMZ for jumping into your VMs, but you still require VMs behind the scene. And you could just have a classic jump box, which I've also used in the past as well. Many options. There's more than this as well, but it just essentially the takeaway here is make sure you think about this beforehand, because you'd be surprised at how many times people lock everything down and then realize that they themselves can't get in, which isn't any good. Okay, so we've got our network. We understand where it sits within the architecture of the organization. We've thought about the sizing of it. We've then thought about how things are going to get out, how things are going to get in, how we can restrict things from getting in and out as well. And we thought about how we're going to get in ourselves. Now we want to think about, okay, how do I bring the services that I want to use into my private network, right? Because all the services, especially when we're talking about PaaS services in Azure, are public by default. They have public endpoints associated with them, which are tied to public IP addresses, right? Before I go any further, I just want to make sure no one has any questions. Do feel free to shout up if you do, or pop stuff in the chat. Or just anything to make sure that I'm not just talking to myself for an hour. Feel free to use the emoji reactions as well. Cool. If no one has any questions, there we go. Brilliant, thank you. So Azure Private Link. I love Azure Private Link, and people think I'm being sarcastic when I say that, but I'm not. I genuinely really love it. I think it's a great invention, and hopefully I'll convince you of that as well. What is Azure Private Link? So you may have heard Azure Private Link being used, and you may have heard Azure Private Endpoints being used. People often use the terminology interchangeably. But it's not. They're very similar, but they're not actually the same thing. So Azure Private Endpoint is like an actual resource. So you would deploy an Azure Private Endpoint. Azure Private Link is just the name of the Microsoft technology that underpins it. So you would say, I'm using Private Link within my data platform, or, is Databricks Private Link generally available? But then you would also say, I have deployed a private endpoint for my SQL database. So very similar, but one's a concept, one's a thing. Azure Private Endpoints can be used to securely access pretty much any Azure PaaS resource instead of using the default public endpoint, right? Any default public endpoint of a resource can be replaced by a private endpoint. And it's important to highlight that, a resource could provide many different services. So they could have many different endpoints, right? A storage account is a really good example. I think there's 6 services that a storage account provides, and therefore there's 6 public endpoints by default. You've got blob, DFS, file, queue, web, and table. So you need to think about which of those services do you want to replace with private endpoint. You might only be using blob, right? In which case you only need to create a private endpoint for the blob service. What does a private endpoint do? I like to think of this as bringing services into your VNet. And again, I'll sort of use the bank to kind of explain it. Imagine I live across the road from the bank, right? And in this example, the bank is the service that I want to consume, like an Azure PaaS service. And my house is my VNet. It's safe, it's secure, and I don't really want to leave it, right? And let's say I live in a particularly rough area, and anytime I leave my house, I'm at risk of being punched in the face, right? If that was the case, I wouldn't really ever want to leave my house to go get to the bank. So the front door to the bank that's across the road, you can think of that's like the public endpoint, right? It's a public entryway that everybody can use to a Azure service. The road is the internet. I could leave my VNet, leave my house, and go across the internet to enter the public endpoint of a resource, but that's not very secure, right? What private endpoints do, and what Private Link does, is it essentially creates a magic portal inside your house that when you step through it, you're automatically inside the bank, right? It creates a doorway inside your VNet to the direct to the service that you're trying to consume. Okay. And so in the bank example, it means I don't have to leave my house. And in the cloud example, it means you don't have to leave your VNet. Your network traffic is never leaving the VNet. It's never going onto the internet. It's not even going onto the Microsoft backbone. It's staying inside your VNet and almost teleporting magically straight to the Azure PaaS resource, right? So that's the power of Private Link, and that's why I love it so much. And you can hopefully see from that illustration why it's so much more secure than using the public endpoints. As I said, private endpoints are a resource in their own right. So you deploy them, you attach it to a resource, and a network interface card also gets deployed alongside it, which holds the IP address information. So enough of me just waffling on. Let's look at an actual example. So I've got my hub and spoke architecture again. I've made my spoke bigger here because it's kind of the focus. And I've got a SQL database in here that I've deployed a private endpoint to, and that symbol there is the private link symbol. So when you deploy a private endpoint, you deploy it inside a subnet. You give it a subnet to pick its IP address from, and it will assign an IP address to that private endpoint. And that becomes the doorway that's only usable for your VNet and things connected to your VNet. It's no longer accessible. Well, if you disable public access, it's no longer accessible by the internet. So if I have a user who's on the corporate network in the office, maybe they connect to the Azure network via the express route, it goes into the hub, the firewall lets it through, it goes down the VNet peering to the spoke, and it goes into the subnet, and it goes straight to that private IP address, and everything is all good and well because they're within the private network and they're allowed to get there, right? What happens if someone's outside of the network is they will instead be taken to the public endpoint. And if you've turned the public endpoint off, they won't be able to get in. So you can see how it's more secure. So you need to decide whether you want to use Private Link. You might need to add those private endpoints into your infrastructure, into your architecture. If you're using infrastructure as code, maybe Terraform or Bicep, you need to make sure you're deploying those resources as well. And you also need to make sure that you're turning off public network access on all of your resources as well. So there's a little bit of extra stuff that you need to do as someone who's responsible for deploying the data platform. Okay, now, Azure Private Link does not work without integration with Azure Private DNS. DNS is kind of horrible. Everyone hates it. And I always say 9 out of 10 times if you're having network issues, it's because of the DNS. So it's a good thing to know the basics about. I think it saved me a lot of headaches just knowing a bit about DNS because, like I say, most of the issues I face are because the DNS is not quite right. So it's worth knowing like what needs to be set up basically so you can check and confirm that it's configured correctly. So a bit of background on DNS in general. DNS, public DNS, is like a huge public phone book in the sky, right? It's a big mapping of, or a big list of mappings between domain names and IP addresses, because as humans, we like to use domain names, but computers like to use IP addresses, right? So anytime you type in a domain into Google or whatever, it gets sent to the public DNS servers, it returns an IP address so that your computer knows where to go. Private DNS is just a private version of that lives within your estate, right? And instead of mapping domain names to public IP addresses, your private DNS solution needs to map domain names to private IP addresses because we're using private endpoints, right? So we're talking all about private IP addresses here. And whilst it's possible to have many variations of custom DNS solutions within Azure, you would nearly always need what are called Azure private DNS zones for use with Private Link. So that's the concept that you need to be aware of. And an Azure private DNS zone, I like if a public DNS server is like a public phone book, I like to think of the Azure private DNS zones like the contact list in your phone. right? It's still a mapping of names to phone numbers, but it's private to you, and only people who have access to your phone can use it, right? And it's not got everyone in the world. It's only got things in that are relevant to you and your immediate environment. That's what a private DNS zone is. So let's have a look at how this would play into our scenario. So I'm going to take the previous example that we looked at on the previous slide, and I'm going to extend it to show you where DNS comes into play. So we've got our SQL database with a private endpoint in our hub and spoke architecture as before. And this time I'm going to deploy a private DNS zone in the hub, and we'll talk a bit more later about why that should be in the hub. But I'm going to deploy a private DNS zone, which is specifically for use with SQL databases. Now, what happens when this user tries to go to the SQL database? They're probably going to use like a connection string, right? And so what happens is that triggers a DNS query. And because they're on the private network, they should, if it's configured correctly, have access to the private DNS zone. So that DNS query gets sent to the private DNS zone. And the DNS zone looks at that domain and it returns the associated private IP address. And so the client, or the server, whatever the person is using to connect to the SQL database, goes, 10.0.1.8, cool, I'll take you there. And then we have the route that we saw before. What happens with someone who's not on the network is when they try to connect to the database using exactly the same connection string, they won't have access to the private DNS solution or the private DNS zone. And so their DNS query will get sent to one of the many public DNS servers, and that will return one of the many public IP addresses that are associated with the Microsoft SQL database service, right? And that IP address there is a genuine one. You can find the list of all of the public IP addresses for every Azure service in every region on the Microsoft website. So not very secure. And so that's why they get taken to the public endpoint instead of the private endpoint, and they won't be able to get in, right? But you can also see without the private DNS zone, the person within the network also wouldn't be able to get to the private endpoint. So if you want to use private endpoints, needs to be integrated with a private DNS solution. Again, you probably wouldn't be responsible for configuring or setting up the private DNS solution. Your organization may already have a central DNS solution set up, depending on how advanced they are in the cloud. But you need to be able to integrate with it, or you need to know to ask to be integrated with it. So a bit on private DNS zones, I mentioned that they should be central, they should live in the hub. There are reasons for that I'm not going to go into the detail of now, but there are valid technical reasons where it breaks if you don't have a central set within each hub and spoke architecture. So you would expect them to be in the hub, so don't go creating random private DNS zones, which some people do because they don't know enough to know how it works, but they've read that they need them for private links, so people start spinning them up and it causes all sorts of issues. So important to know that you shouldn't do that and that they should be central. I mentioned in the previous example that I was going to create a zone for SQL database, and that's because you have one zone per domain. So you'd have a central set of private DNS zones for every service that you're using. So you might have a zone for SQL databases, you might have a zone for key vaults, a zone for blob storage, etc., etc. And the names of these private DNS zones have to be very specific names. You can find it in the documentation online, but you can't just call them anything. They have to be named after the domains that they're responsible for. So that's important to know. And they're also reusable. So, if you have one DNS zone for all key vaults, you would expect to see DNS records in there. And we'll talk a bit about DNS records in a bit. You'd expect to see DNS records in there for your entire Azure estate, dev, test, and prod. So you can see they're very you should protect these resources, right, and not be giving people access to them, because if people mess around with them, it could bring down production systems. And this is an example of how it kind of tracks through. So if you have a resource called SQL DB West Europe 01, then the domain, the FQDN, fully qualified domain name that you get associated with that endpoint will be the resource name .database.windows.net. The domain that FQDN is sitting on is the last bit, database.windows.net, and the associated Azure private DNS zone that sits alongside that domain is called private link.database.windows.net. So you would expect to see a private DNS zone resource with that name. Now, it looks like you can just say, I'll just put private link at the front of them all. They're not all one-to-one. Some of them are not, like Key Vault isn't, for example. So always good to check the documentation. Again, you may not be responsible for configuring these private DNS zones, but if you are, important to kind of understand this stuff. Okay, A records. I mentioned that your private DNS zones house your DNS records. Private DNS zones, when you first deploy them, are completely empty. Kind of like when you get a new phone, your contacts list is empty, right? They're very simple resources to deploy. You just give them a name and that's it. You don't even give them a region because they're central. So you have to populate them with DNS records. Now, specifically for private link, you use what are called A records, which is a specific type of DNS record. And an A record is one of the more common DNS records that is the one that we've been talking about, where it maps a domain name to an IP address. And that's all it does. So you can see an example of one here at the bottom. And if we click into it, you can see the actual domain name. It's the private link version of it, but it's the domain name and you've got the IP address at the bottom. So I'll just skip back a slide. So you can see here I've got my private link.database.windows.net private DNS zone, and I've added an A record in there. And that's so that if you remember the architecture from before, when the person's initiating that DNS query to the zone, if there's no A record in there, then the zone's not going to be able to reply with an IP address, right? It's not magic. You have to populate it with that mapping, so that when someone initiates a DNS query to that zone, it's able to correctly reply with the right IP address and then send that person to the right endpoint. Okay, so this is the bit that you really need to be aware of. Whenever you create a private endpoint, it will ask you, do you want to integrate with DNS? And what it means is, do you want me to add an A record for you in a private DNS zone? Now, usually you'd want to click no, because you won't have permission to do it. And what it'll do is it'll be like, oh, I'll create a new one over here and I'll do all this. And you don't want it to do that. So usually you want to ask, whoever's responsible, central networking and infra team, to be like, hey, I've deployed some new private endpoints. Can you please add relevant A records for me to the relevant private DNS zones? And if they don't know what that means, or they don't know what zone it is, that's when having a bit of knowledge of, oh, well, here's the list from the documentation of all the different private DNS zones, it should be this one, can really make things go along a lot quicker. Okay, that's A records. So we've talked about how does our network fit in the larger network architecture. We've talked about how big our network needs to be. We've talked about how we can restrict and monitor things coming in and out. We've talked about how we can get ourselves in. And then we've talked about how we can sort of bring services that we want to use into our network as well by utilizing private link and integrating with private DNS. At this point, we've not actually built anything. We've not actually deployed anything. So you can see that, like, there's a lot of upfront thinking that has to be done before you even get to this point. So it's not a light decision to suddenly just decide to, deploy things into a privately networked architecture. But we are now at the point in the talk where we're ready to think about, okay, what actual services do I want to use? And unfortunately, again, deciding to deploy within a privately networked architecture brings a lot of complexities with a lot of services and things that you have to do differently or consider how you're going to make work. So this is not an exhaustive list, but I'm just going to talk through a couple of different technologies that I have familiarity using and some of the considerations that you have to think about when using these tools and technologies in a privately networked environment. So the first one I want to talk about is Azure Data Factory and integration runtimes. Now, I'm not talking about Data Factory inside Fabric here, and I will talk about Fabric in the next section. I'm talking about Azure Data Factory, ADF, here. And that's because ADF has a concept of an integration runtime and Fabric doesn't. Hopefully people are familiar with the concept of integration runtimes. Integration runtime is just the compute that Data Factory uses to do its lifting and shifting. When you're inside a private network, though, you've got to consider, how is that compute going to be able to talk to my privately networked resources, right? Maybe I've got a storage account that's behind a private endpoint. Maybe I've got a key vault that's behind a private endpoint. And I need my ADF to be able to interact with these resources. So what this means is you can no longer just use the default out-of-the-box option of the Azure IR. The Azure IR, the Azure Integration Runtime, is like a serverless runtime that's provided for you by Data Factory, but it doesn't have access to your private network, so you can't use it, at least not with the default settings. So there's two options that you can use. You can use the Azure IR, but with the managed VNet option turned on, or you can use a self-hosted integration runtime. What is the difference between these two? Well, Azure IR with managed VNet, it utilizes the Azure hosted integration runtime, but you turn on the managed VNet option, which means that it's still serverless. It's still, you don't know where it is, but you have the kind of security of knowing that it's in a VNet, but it's not your VNet. It's a managed VNet that Microsoft's handling for you. Now, since it's a managed VNet, it's not your VNet. Going back to the house and the bank example, you can kind of think of it like your neighbor. Maybe your neighbor's doing a bit of work for you or something, and they also need to access your bank account. You having a magic portal in your house to the bank doesn't help your neighbor, because they'd have to leave their house to get to my house to use the magic portal, right? So again, me having private endpoints in my network for my resources to talk to each other doesn't help the Azure IR with managed VNet. So you have this concept of managed private endpoints, which are private endpoints for the managed VNet. So I won't go into detail about how to set them up. They're not too complex to set up, really, more simpler than normal private endpoints. But it's just being aware that if you want to use this, you have to then configure managed private endpoints in order for the runtime to be able to talk to your privately networked resources. The self-hosted integration runtime, or the SHR, is created by installing the integration runtime application on your own machine. This could be like an on-prem server or an Azure VM. And since this server is sitting within your network, i.e. it's in your house, it can make use of your existing private endpoints to securely connect to your protected resources. How do you choose between the two? It's quite tricky, really. For me, it comes down to one deciding factor, which I'll talk you through, because there's a bunch of pros and cons to each one. So the Azure IR with managed VNet, pros, fully managed and serverless, which is just nice, right? You don't have to think about it. And with that comes a nice elastic scaling. You don't have to maintain any firewall rules because, again, it's not in your network. It's a fully managed network. Cons, you have no control over the address space that it sits in. Not really a con, to be honest, but a lot of people don't like it. A lot of clients just feel funny about not knowing where their data is being processed. They don't know what address space it's being processed in. So sometimes a blocker that I've come up against when trying to use this. As mentioned already, it requires additional private endpoints. It can increase costs. So on a per activity basis within ADF, it's more expensive. And it can also increase your queue time on an activity, because unlike the Azure IR, where it kind of pre-provisions you a node and keeps that node warm for you, it doesn't do that with the managed VNet. It has to create a new node each time, and it has to create a new VNet each time, and it has to attach the node to the VNet. So you end up seeing longer queue times on your activities just because you're waiting for that to set up. And obviously you pay for that, right? Something to be aware of. And the biggest con for me is it doesn't work easily with on-prem connectivity. I say it doesn't work easily because it is possible, and it's a really horrible solution. I do have a blog on it if you're interested to see the architecture. I have implemented it once. It wasn't very nice, and I wouldn't recommend it. So self-hosted integration runtime, you have high availability options. So you are installing an application on a server that you own. So you can have multiple servers, install it across multiple servers, and connect them all together to one integration runtime in Data Factory. So it gives you high availability. The runtime costs are cheaper. So per activity within ADF, it is cheaper. Big pro, it allows for easy connectivity to on-prem data sources simply because it exists within your network, right? Nice and easy. It does still require pre-existing infrastructure, right? Like if your current network isn't already set up with on-prem connectivity, then the SHR is not going to help you. That all needs to exist. You or someone within your organization is responsible for providing and maintaining the server. So you're introducing IaaS or on-prem infrastructure. You have to maintain all the firewall rules. You are responsible for ensuring that your server can connect to the data sources and can connect to Data Factory. So you have to look after all of that. And then although the runtime cost per activity are cheaper in ADF, you are now paying for a VM, right? So you've got to consider the compute costs there as well. Sorry, the compute resource costs. So for me, a lot of these kind of outweigh each other, but the biggest differentiator is the on-prem connectivity. So we tend to go for the rule of thumb of if you're connecting to an on-prem data source, use Azure. If you're not, use the Azure IR with managed VNet. And there is a hybrid approach as well, which again, I talk through on one of my blog posts if you're interested to read more. There is a hybrid approach of using both of these, right? You can use the Azure for on-prem stuff and use the Azure IR with managed VNet for stuff inside the cloud. There's nothing stopping you from doing that. Okay, Fabric. Sort of a cross between Data Factory and Power BI in terms of the network connectivity piece. So Fabric has a concept of a data gateway, which you may be familiar with. It's very similar to the concept of a data gateway in Power BI. But like Data Factory, there is an on-premise data gateway, and then there is a VNet data gateway. The on-premise data gateway is kind of the Fabric version of the self-hosted integration runtime, and the VNet data gateway is kind of the Fabric version of the IR with managed VNet. So how do these work? So for the on-prem data gateway, we have our Fabric environment, and we have OneLake within there. And then let's say we have our on-prem environment with a SQL server installed on a server. And we need to create a connection in OneLake to a data set on the SQL server, right? So what we would do is we would install a data gateway application similar to the self-hosted integration runtime. We'd install it on the server, maybe on the server itself, or maybe on another server that lives on-prem. You would sign in and you would configure it on the actual installation of the application itself. And this then, when you configure it, connects it back up to Fabric. So it sort of instantiates that connection. The on-prem data gateway is on the same server as your data source, so naturally it can talk to it. And then because you've configured it and connected it to Fabric, it can talk to OneLake as well. So then what happens when you go into OneLake and you create a new connection, you select on-premises for the data gateway, and you'd be able to select your data gateway from the drop-down and build your connection using that gateway. For the cloud, you would use a VNet data gateway. So similar setup, we've got our Fabric environment, but this time I've got a SQL server or a SQL database in a spoke, in a hub and spoke architecture. It's a standard hub with a firewall there. Now for this one, you don't need a server, you don't need to deploy a VM or anything like that. All you actually need is a subnet. So there is certain stuff you need to configure on the subnet. You need to do what's called subnet delegation, which is a concept in Azure where you sort of give Azure power over your subnets to different services. So this one has to be delegated to Microsoft.powerplatform/VNet access links. It's just a setting on the subnet. And then instead of creating a VM and installing the app in there and configuring it, you just leave the subnet alone. And then you go back into Fabric, and you go to manage gateways and connections, you click create new VNet data gateway, and it just asks you what subnet do you want to use. And you click the subnet, and Fabric just creates a VNet data gateway for you. And you won't see it, like you won't see a VM or anything like that, but you'll see it within the Fabric portal listed there. And you just know that it's connected to that subnet. It's using that subnet address space for this compute. And so Fabric can talk to, the Fabric can talk to the gateway because you've configured it within Fabric and you've told it which subnet to use. So it's sort of created that connection. Now, I would recommend putting the VNet data gateway somewhere central in the hub so you can share it across multiple environments or multiple spokes. When I last checked, that's not what the documentation recommended. It recommended putting it in the spoke, but that would mean a lot of subnets that you have to create for every spoke that you have, which seems wasteful to me. So I would recommend putting it in the hub. And then we could, for example, utilize our user-defined routes from before to route all traffic from that subnet through to our firewall, and then allowing the firewall to pass it down to the spoke to the data source that I'm trying to consume through Fabric. And then again, you would go into Fabric, you've created the gateway, so now you want to create a connection that uses that gateway. You would click new connection, and this time you would select virtual network. And again, on the dropdown, you'd be able to select your VNet data gateway from that list. So quite nice and simple, actually. Cool, Azure DevOps. So again, Azure DevOps, similar to ADF, Azure DevOps needs compute to build stuff and compile stuff and deploy stuff, right? So whenever you're running pipelines in DevOps, you have to attach it what's called a build agent pool, and that build agent pool has build agents in it, which are essentially servers. And if you've never had to think about private networking before, you might not have even thought about it that much, because by default, you can use the default Azure hosted build agents. Again, you can't use that when you're working in a privately networked environment because those Azure hosted build agents live somewhere else. They're serverless and they don't have access to your private network. So again, it's another thing that you have to consider. So you have to create your own self-hosted build agents. Now, you can create a virtual machine and install the build agent on there. Obviously, that does introduce IaaS into your infrastructure. You can now use virtual machine scale sets as DevOps build agents as well, VMSSs. So if you don't want persistent IaaS, you can use VMSSs where they spin up ephemeral VMs and you connect that to DevOps. The screenshot I've got on the screen is how you configure a build agent on just a static VM. It's slightly different for configuring the VMSS. Again, not something that maybe you yourself would be responsible for configuring, but you might be responsible for requesting it. I'm on a project right now where I've had to request, I actually need a Linux self-hosted build agent because I want to run Docker commands for building an image to push to an Azure Container Registry. And it's in a private network, so I can't use the Azure hosted ones. And all of their current pipelines use Windows build agents. So I've had to request a new server to be created. But, I know enough to be able to request the very specific thing that I need, which has made it go a lot quicker. So let's have a look at an example. So I've got a hub and spoke architecture here. I've got things in my hub like my firewall. I maybe have a gateway subnet that connects to my express route. And then it's not uncommon to have like a central set of servers within your hub that are used for various different things. So that's the example I've gone for here. So you might have a Bastion host. You might have a bunch of shared self-hosted integration runtimes that you can share across multiple data factories. And you might have some shared self-hosted build agents in there that are sort of shared across multiple DevOps projects. And so what happens when you kick off a pipeline in Azure DevOps? That sends a request to the server to build whatever it is that's on your pipeline. So in this instance, we're giving it a SQL proj file and asking it to build a DAC pack. So it goes ahead and builds the DAC pack. And because the server is within the private network, it has access to my SQL database private endpoint. And so it's able to successfully deploy the DAC pack that it's built to the private endpoint of my SQL database. If I was using the Azure hosted or the Microsoft hosted build agent, it would run the build, but then it wouldn't be able to do the deployment because it'll try to go to the SQL database endpoint. And as we saw before, it would be directed to the public endpoint, the public IP address, and it wouldn't be able to get in. So another important one to consider. And then last but not least, I want to talk about Databricks a little bit. I don't know if anyone uses Databricks here. I use Databricks sort of quite a lot in my job. We're Databricks partners as well as Microsoft partners. So most of our Lakehouse platforms are built within Databricks. Databricks has a lot of networking features and I find it quite interesting. You might think I am sad for thinking that, and you would be right. But I just wanted to talk you through them kind of at a high level of what's available when you're talking about Databricks. So Databricks uses clusters, and those clusters have to live somewhere, right? Those clusters are computers, they need IP addresses. So there isn't really a concept of deploying Databricks without any VNet, but the default least secure version is to deploy it with a managed VNet. So that's kind of at the bottom, and we'll go through these in more detail, so I'll kind of skip through them a bit quicker now. The next option up is VNet injection. So instead of the clusters living in a managed VNet, you instead bring those clusters into your own VNet. Then on top of either of those two options, you then have a concept of secure cluster connectivity, which is to do with how your clusters talk to the Databricks control plane. And then on top of that, you now have Azure Databricks Private Link, which has been GA for about a year now. So let's have a look at these couple of architectures. So managed VNet, you have your data platform VNet over on the left. Microsoft creates a managed VNet for your Databricks clusters. Databricks clusters always require two subnets. One is called private and one is called public, and it's to do with how it communicates to the Databricks control plane. So by default, you'll have a private subnet, a public subnet, and then it uses public IP addresses it piggybacks from the subnet to public IP addresses to talk to the Databricks control plane. As I mentioned, you can add secure cluster connectivity, or SCC, sometimes known as no public IP or no PIP on top of this. And what this does is exactly the same, but you'll see instead of a public subnet, you get a second private subnet. Thank you. And instead of using a public IP address to talk to the Databricks control plane, it uses what's called a control plane relay, which is essentially, it's the reverse of a secure channel. So it doesn't have any open ports in your environment. We don't need to go into the details of that, but it's a bit more secure. There's no public IP addresses in play. VNet injection is very, very similar, but those two subnets live in your VNet. You create those subnets, and when you're building the Databricks workspace, you say, here are the two subnets that you can use. And again, there's that concept of subnet delegation that we mentioned earlier. You delegate it to the Databricks Microsoft provider. And Databricks uses those for your clusters. And again, by default, you will have a private and a public, and it will use a public IP to talk to the Databricks control plane. So again, you can add SCC onto this, which turns your public subnet into a private one and uses that control plane relay, the secure channel, to talk to the control plane. And up until last year, this was the most secure way to deploy Databricks. Now we have private link, which we should all know everything about from earlier in the talk. I'm not going to spend too long going through the detail on this, but essentially, if we have a Databricks workspace, right, I want to add a private endpoint to that workspace. I'll put that private endpoint in the same subnet as the other private endpoints that I have. I have a SQL database one here as an example. And what this does is it brings the Databricks control plane service into my VNet, right? Like the bank example, brings it into my VNet so that my clusters, when they want to talk to the control plane and vice versa, they never have to leave the VNet, right? That traffic never has to leave. So everything can just communicate to each other nice and securely. What's also cool about Databricks Private Link is you can, that's data plane to control plane traffic, but you can also protect end user to workspace traffic. So when someone's logging in, for that, it actually requires an extra private endpoint, which handles browser authentication. That one lives centrally because it's on a per regional basis. Again, without going into too much detail, but you need another workspace in the hub that you can attach that central private endpoint to. And when users try and log into a workspace, what happens is they get sent to that private endpoint. That private endpoint does some funky stuff with Entra to check that that the user can log in. And then that forwards you back to the old private endpoint, which again has access to the Databricks workspace and everything inside it. So you can completely restrict everything with Private Link, which is really nice inside Databricks. And that's end users workspace. Last but not least, I want to touch on NCCs in Databricks, or network connectivity configurations. Bit of a mouthful. And again, it's this concept of serverless, right? Everyone wants to use serverless, and we've seen in some of the earlier examples, like DevOps, that you just can't use the serverless option when you're working in a privately networked environment. And you're kind of relying on the service provider providing you with a solution in order to be able to use serverless. And that's what's happened with Databricks up until maybe like 6 to 9 months ago, maybe even just 6 months ago. This wasn't available, so you just couldn't use serverless in Databricks if you needed to connect to privately networked resources, but now you can. So I've got my tenant on the right over here. I've got my resource group in my Databricks workspace. I have my VNet. I've got a private endpoint for my Databricks workspace, and I've got my subnets for my clusters because I'm using VNet injection, right? Which is all well and good if my clusters need to speak to, let's say I have a storage account, right, that's privately endpointed. If my clusters in my VNet want to talk to my storage account in my VNet, they can, right? But what happens when I want to use serverless compute to talk to my storage account? That's in a different tenant, in a different subscription, in a different resource group, in a different VNet, in a different subnet altogether, right? And again, like I said, without Databricks providing functionality here, you're kind of screwed. There's no way for you to force that route through. right? But what's nice now in the Databricks account console, which is kind of where you manage your Unity catalog stuff, there's now a concept of a network connectivity configuration, or an NCC, and you create one of these, usually per environment, and within it you just create links to your various different privately networked resources, and that enables connectivity from serverless to whatever resources you've listed. Now, up until like I think last month or maybe 2 months ago, you could only do this for storage accounts. But now you can do it for any privately endpointed resource. So Key Vault, SQL Server, anything you want to connect to from Databricks, you can use an NCC for, so that you can use serverless compute to securely connect to it, which I think is pretty cool. Cool. So, bit of a whistle stop tour of a couple of different resources, but hopefully kind of highlights to you that making a decision to deploy everything in a privately networked environment comes with a lot of other considerations that you then have to think about. How are you going to get everything to work, and how are you going to get everything to talk to each other? I do have another talk, which is a full 60 minutes all on private link. So that is on YouTube. So if you're interested more about understanding the private link, and I go into depth on the private DNS, there's a QR code for that. There's a QR for the particularly nasty ADF integration runtime blog if you're interested to see that architecture diagram. And again, another link to my community content GitHub, where you'll be able to find all of these slides and the architecture diagrams as well. So yeah, I think we're okay for time, just under an hour. Thank you again so much for being with me this evening. I really appreciate you taking your time to listen to me talk to you about what often people argue is a boring topic. Hopefully you didn't find it boring. Hopefully you found it useful. And if anyone does have any questions, I'm happy to stick around. Again, feel free to connect with me on LinkedIn. But yeah, thank you so much, guys.